right, welcome back. This is the an extension to or add-on to the compiler design course where we're talking about ARM assembly language with the goal of eventually building our own little ARM-like virtual machine, a simplified ARM-like virtual machine. For the moment, we're taking a look at assembly language and getting an understanding of how an ARM processor would work at this level, because we're going to have to work with one. One of the things I want to go in today is a little bit about other system calls or other ways of calling system library functions. If we look at, and here we'll use this bigger terminal so that we can see things. If we look at slant user slant ARM, ARM Linux GBI, we'll look at the HF one. In here is a lib directory, and you'll see there's a whole bunch of libs. These are libraries specifically to our ARM Linux GNU setup, and they are the standard libraries that you would find in a Linux system. And right here, somewhere here is lib, well, there's libc.so, libc.so6. Okay, these files contain the stuff you find in C programming, like printf and scanf, and they, of course, are those programs, and they are written for this. And in our assembly language program, we can take advantage of that. Now, in the first one with hello, we used a system call to just spit out the string, but we don't have very much control over this. So instead of using a system call, let's build up a program to call upon those functions in the standard libraries, just like we would in a C program. So we're going to set up just like we did before. We're going to create a data section. Now we are going to do something a little special here called balign 4. We want to align each of these messages to 4-byte boundaries. That has to do with calling into these other calls in the library. We didn't do that before. We didn't need to with a regular system call, but calling these libraries, it's a good idea. It may not always cause a problem, but by aligning to 4-byte boundaries, you'll have less problems with the standard libraries. Let's create a message 1 of type dot ASCII Z, and let's type in enter a number, and let's put a colon and a space. Now, before I use that little math thing to figure some things out, but we don't really have to worry about that for this, because in these calls it's going to so the system call that we called to print out before didn't care about the 0 at the end of our ASCII Z string. It cared about the length, which is why we had to calculate the length. So we're going to balign 4 again, and create message 2. Oh, this was message 1. Message 2, ASCII Z, you entered the number %d slant n quote. And then we need balign 4, and we need a pattern for our reading the number, and that's just going to be we're going to look for %d, a single number. That's what we're going to scan for. And then balign, we need one called number, and this will just be a word, and we'll set it, initialize it to 0. And a return code, which will be 0.text. So we've got our messages set up, and it's very similar to what you would find in C or C++ code. We got the %D here, which is going to be where the number gets put in. This is the pattern we're going to scan for when we scan. So now we need our main function, main. And we create it, main, main. Now, what do we need to do? Well, let's LDR to R1. Well, first of all, before we start typing code, I'm going to come down here and create some labels so that things are a little bit more clear. I'm just going to paste these in, but I don't think I called them that in this. This is message 1, message 2. This is just pattern, and this is number. I did this a little bit differently this time, so so these are labels, and they create a memory location at the end of our code here, a labeled memory location that contains the address of message 1, and it just makes it a little bit more clear what we're doing. So we've got our return is the address of return. Where dot return? Oh yeah, we put it up there. Okay. That's the return code. Okay, so we're going to load that into R1. LDR R1. I don't want to confuse myself. I'm looking at my notes here. So we want the address of return. So when our program exits, R1 contains the numerical value, or in this case, the address of the numerical value of what we want to return. And LDR, LR, 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 BX, LR. Yep. Okay. Just verifying. So this is going to contain the address of our return value up here. All right. We're going to go str lr r1. So what is that? Str is store. Whatever's in the link register. That's one of those special registers that we talked about. It's one of the higher numbered values. I think it's 14. 15 is the program counter. 14 is the link register. It's either 13 or 14, I forget, but it's the link register. This is sort of like a place where when we branch, certain branch instructions will store the current program counter. That's the current place we are in the execution of the code into the link register. That way we don't have to use the stack and push and pop all the time for simple calls that are going to simply return. So what is this code doing? That was supposed to be RL. That was supposed to be R1. So what is this code doing? Store. Store stores into an address. So we loaded register 1 with the address of return, which is this address up here of this 0 right now. It's initialized to 0. Store is going to take whatever's in the link register and store it into that location. Let me verify that. Let me verify that I'm explaining that correctly. ARM assembly str immediate offset. Stores with immediate offset, pre-indexed immediate offset, or post-indexed immediate offset stores. Yeah. Yes. Okay. So it stores. It's storing into this address or this location the value that's in the link register. This is so that we can get back. All right. Now there's some other things I'm going to add down here so that I'm going to put them in first so that you know why we're calling them or how we're calling them. And that is right down here after all of these, I'm going to put these in. I'm going to declare a function global printf and scanf, or labels really. These are labels. Printf and scanf. The assembler is going to see those, and it's not going to see them in my code anywhere, and it's going to go looking for them, and it's going to look for them in the standard libraries that it's linking to, and it'll find it in the libc, or clib, yeah, in libc, right, the one we just looked at. Where was it? Oh, it was in here, right? This one right here. That's where it's going to find it in libc.so.6. And the same thing with scanf. It's going to find it. So that's what we're going to do right now is we're going to call printf. So we're going to LDR register 0 with the address of message 1. And we're going to branch and link to printf. So what's branch and link going to do? Branch and link is going to first take our current address we're at and store it in the link register. Then it's going to call branch to printf. Printf is going to return to the address in that link register, which is going to be right here, right where we left off, so that we're back in place. Okay? And that's also why we stored the link register up here. All right. So we printed out our message that says, what's it say again? It says enter a number. That's our message. All right. Now we're going to, oops, I don't like in caps. So we're going to load a register now. R0 with LDR R0 with address of scan pattern. Okay. And then we're going to LDR R1 address of number read. And we're going to branch and link again to scanf. So what's that going to do? Well, it's going to call scanf, same thing. It's going to store the appropriate address in the link register. It's going to branch to the scanf function in our libc library that we're going to link to, and scanf is going to read from the keyboard and when it matches the pattern that's sent in register 1, register 0 is like the first one, the pattern, and register 1's like the second parameter, the address of the number read, which is where we want to store the number it reads. It's going to read that number typed in the keyboard, convert it to an actual number because of the pattern, the %D, that tells scanf to turn that into a numerical value, and it's going to store it at this address that we read. Okay? Now, we're going to do the same thing, LDR R0 with address of message 2. And now message 2 has that %D in it, so we're going to LDR R1 with the address of the number read. So this is going to tell the printf parameter 0 is the message and parameter 1 has a number in it. It's going to look in those registers to fulfill that that %D that's in the printf, and we're going to then branch and link to printf. And then we're going to LDR R0 address of number read. LDR. I'm not sure why I did that. R0 number read. R0. Oh yeah, R0. Now I remember. R0. And we're going to put this in brackets here, R0, just like we did up here with R1. So this was the address of return. We used that address that's in R1 inside these brackets to tell it where to store to. Now we're telling it to load the register. This is store register. This is load register from the address in R0 back to R0. And then we're going to LDR the link register with address of return. And then we're going to LDR LR from what's in LR. So now LR contains what was stored at that address. First it had the address of return, now it has it. And then we're going to BX LR. So this is a branch exchange. We did BL here, which is branch and link. Branch exchange is going to swap the LR with the program counter, which, because we just put it the return address in, is going to exit our program. And I believe that should all be working. Let's do a let's update our make file first of all. We're going to make this hello2 now. And what doesn't it like? Address of message 2. Undefined reference to message 2. I probably made a typo. Hello2. Here's message 2. I did. It's supposed to be message 2. And they compiled and linked. So now we can do run sh boot, and it says enter a number. Let's enter 42. It's one of my favorite numbers. And it says you entered number -69573. But it returned with the exit code 42. -67583. What did I do wrong? I missed something here. I messed something up. Let's see. It's got to be related to address of message 2, address of number read, R1. Oh, yeah, because I missed a statement. We're going to load the register R1 from what's stored at the address stored in R1. So what this is doing with the brackets around it, it's saying, don't give me what's in R1. Go to the address pointed to by R1 and get that information and put it back into R1, basically overwriting the address that I had stored there. Let's do that again now and see if we get the right answer. We'll type in 42, and you entered the number 42. Let's do this on the big screen so we can see it more easily. We need to be up 1, dot slant, run arm. Actually, let's do clear. Let's go run arm, boot, enter number 42. You entered the number 42, and 42 is because the output 42 here is because it's also returning that value as the return code, whatever I typed in. That's why we moved it to that address of number red. So that's it. We called both printf and scanf in the standard C library from assembly code in ARM in a pretend ARM processor, which is our QEMU emulator. So that's a little bit more about assembly language. We to cover, just give a quick go around of what we talked about. We talked about alignment, not in a great bit of detail, but we'll talk about that a little bit more. We talked about these various instructions, loading registers. We talked about branching now, branching and linking, and calling into the C library, and some clever ways that you can create addresses, labels that hold addresses for things that exist, making it a little bit easier to manipulate them. So that's it for this video. I think we're probably fairly far along. Not too bad this time, 22 minutes. Okay, so I think that's it for this video. Thanks for watching. I hope you liked it. If you liked it, hit that like button. If you really liked it, hit that subscribe button. And I will see you in the next video. Thanks for watching. Have a great day.